Okay, so again, we're on page 228, complete 2A. This is information from yesterday.
I can calculate 4 times 8 times pi method. No, is he sure? So 3. Well, actually, you only did this one. This to get accurate, like, find. Okay, it's 152 6 29 3.141 92655 4. First page. Second page. It says or not to the nearest pi. It's just 16 over. Yeah. Remind me to what these things because these are two very funny. Why does it leave so many papers? I don't know. Well, the other half. Why are they pulling up on their paper? Well, it's already pulled up, so. There is no second
Okay, how we doing? Show of hands who's still working on this one. Okay. So looking at number 2, it says in a circle with radius 4, what is the length of an arc that has a measure of 80? Round to the nearest tenth. So again, if we just wanted to draw a picture of this, here is our circle. We have a radius from here to here of 4, another radius right there, and they're telling us that the measure is 80 degrees. So what did we get as an exact answer? I know it says round to the 10th, but you guys really need to get in the habit of possibly doing both. So what would the exact answer be here? Shane? 16 over 9 pi. Very good. So 16 pi over 9. And then you put that in your calculator and you should get an approximate answer of 5.6. So just to recap, this, oh my gosh, this is an exact answer. This is our approximate answer. Okay? Any questions before we move on? Okay, we're skipping 1, so you can write in some notes in part 1 because we actually had that example on our worksheet yesterday. Okay. Okay, so your I can statement today, find the arc length using radians and sector area of a circle and use them to solve problems. Your new vocabulary today is radian, sector of a circle, segment of a circle. Hey guys, guess what? Welcome to Algebra 2, the stepping stone to Algebra 2. This is important stuff, okay? So what is a radian? It's not just a mode in your calculator. So we have like this arc measure right here. We have this radius, and this is basically a radian is just another way of talking about the central angle, but it's in terms of pi. Okay? Hi. I wasn't expecting you to this so quickly. Calculator only. Yep, thank you. Okay, so a radian is equal to the measure of a central angle that intercepts an arc with equal length to the radius of the circle. So these are just some other pictures that you can kind of use to solidify this understanding. This is 1 unit here. This is 1 unit here. These two are equivalent, therefore you have 1 radian. Okay. If these are 2 radii and this arc should be equal to the radii, giving you a radian. Here's another picture. You have radius. The length of this is also equivalent to the radius. That gives you 1 whole radian, okay? Excuse me. So, this is the overall understanding of what a radian is, okay? That central angle or that length is equivalent to the radius. Okay, so remember from yesterday, we did this arc length, n over 360, so n is in degrees, times 2 pi times the radius. Again, this only works when n is in degrees, so we have a central angle in degrees. But now we're dealing with central angles as radians. How do we calculate that arc length? Okay, so if you're given radians, this is the formula. And I would definitely draw the circle because now we're kind of moving away from x, y's, and z's into alpha, beta, gamma, theta, delta, into Greek. Okay? So in this case, the arc length formula when your central angle is in radians would be s, meaning arc length, times the radius, times the central angle. So that's theta. Okay? Is anybody still copying this down? Okay. All right, anybody still writing? Are we caught up? Okay. All right, so part 2A was our warm-up problem, so that's why that's there. And it says, so for part B, it says in a circle with radius 6, what is the length of an arc that has a measure of pi radians? Find the exact answer and find the approximate answer rounded to the 10th. Go ahead and just apply the formula. Just out of curiosity, who has the exact answer? It is easy. If you're thinking it's that easy, it is. I promise. Nikki? 6 pi, yeah. So now we type 6 pi in our calculator. What's the approximate answer? Ta-da! Not bad, right? You okay? I just read your lips, so I'm asking. You good? Okay. Okay. So we're going to skip example 3. Let's move on to example 4. Okay, so here's something you're going to want to add to your notes for example 4. Probably in that like kind of blue area. A sector of a circle is the region bounded by 2 radii and the intercepted arc. So in general, the area of a sector is A equals n over 360 times pi r squared. This makes sense because remember last time we were doing arc length and we had to do circumference, right? Now in this case, we're finding an area, we're finding just a part of that area of the circle. So it makes sense for us to have the circle area of a circle formula. Wow, I'm having a day. So n is still the number of degrees of the intercepted arc, and r is still that radius. So nothing's really changed in terms of that fractional part, okay? But you do want to write this down and put area, sector, area of a sector. Okay. Who's still writing? All right, so let's talk about this. So what is the area of each shaded sector? Again, I'm going to kind of harp on the whole idea of this exact answer thing, okay? So our first step is to take 165, divide that by 360. That gives us that fractional part that we're looking for. And then this will be pi times the radius squared. Now this leaves me with 165 over 360 times 9 pi. I'm going to multiply the 165 by the 9. This leaves me with 1485 pi over 360. And then just remember from yesterday, we just put that part in our calculator and hit math frac. What do we get? Okay. 33 over 8. So this 33 pi over 8. Sorry that the pi kind of dragged. Try this one on your own. All right. Who has the answer for me? Tony? Very good. 295 pi over 18. Does anybody need to see this? Okay. Let's move on then. Okay, so now let's talk about the segment. A segment of a circle is part of a circle bounded by an arc and the segment joining its endpoints. Okay? So in this case, your goal is, and this is what you're going to want to write down, the segment area is going to be the sector area minus the triangle area. Now, who remembers, how do we find the area of a triangle? 1/2 base times height is one of the ways. What's the second way that you may or may not remember from topic 8? There's that weird one. Yeah, you're getting very close, Shane.
Yeah.
Very close. So just keep in mind that obviously 1/2 base times height. That's our go-to, right? But what happens when we don't have that height and we only have a degree measure? 1/2 the product of the two sides times the sine of that central. It'll be the central angle here in this case. Okay. So this A is probably going to be the central angle. And this right here is going to be the sides of the triangle. Okay. Most likely, the triangle is going to be isosceles at the very least. Because you're dealing with two radii. Okay. So this is just to kind of get you the idea of it's not always going to be 1/2 base times height. Not saying you can't use it, totally can. But 90% of the time it's going to involve trig. Okay. But not heavy trig, right? If we didn't have this formula, it would be very heavy trig, and we don't want that. Okay. All right. Anybody still writing this down? Make sure you have these two formulas, and yes, either one will work. Okay. OMG, please, please be kind to ourselves. Have it written down. Anybody still writing? Okay. All right, so now we're going to find this exact area. Now there are going to be times you can find the exact area and there's going to be times you can't find the exact area, okay? And if in those cases, it will tell you to round. This one we can find an exact area and it's something I want to show you anyway. So the first thing I'm going to do is find the area of that sector, okay? So in this case, I'm going to take 90 over 360. The reason it's 90, I have a right angle right there, times pi times 10 squared. I'm going to skip the whole 10 squared thing. I think we know what 10 squared is. I'm going to multiply it by the 90. That leaves me with 9,000 pi over 360. So my exact answer just for the area of the sector should be 25 pi. Does that make sense where that's coming from? Our next step is we're going to find the area of the triangle. Now this is kind of nice. This is an isosceles right triangle. So that's 10, this is 10. So we have a base and we have a height. So we can use 1/2 base times height. So the area of the triangle is going to be 1/2, pretty much 10 times 10, which leaves us with 50. Now to find this, we're taking the sector minus the area of the triangle. So this is going to be 25 pi minus 50, and this will be in feet squared. That is your exact answer. Think of it like, remember when we did radicals and we couldn't add them up unless they matched? The same thing goes for pi. If you don't have a pi attached to it, you can't add it together, okay? Any questions at all? Okay. Now for this next one, this is a you try it, but let's take a peek at this before we do. Are we gonna be able to use base times height here? We have no base. We have no height. If you want to find them using trig, you're more than welcome to. I don't recommend it though. So to find the area of this triangle, what are we probably going to use? Ooh, not all at once now. Which one? Are we using 1/2 base times height? Or are we using the sine? Sine. Okay. Calculate this, please. Okay, now this one you do need to round to the 10th. Is anybody still working on it? If you are, please raise your hand. How are we doing? Who's got the answer? Leanne, I think you got it. You got the sector? What's the area of the sector? 10 pi. Good. Okay. So the area of the sector is 10 pi. How about the area of the triangle? Now that you had to get a decimal. There's no way around that. Okay. If you can find exact answers with sine in geometry, you should not be in geometry. You should be like way, 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 way higher up. My dad can't even do that. He's got a doctorate in this stuff. Anyway, what we got? What was the decimal equivalent that we got for the area of the triangle? Good. 7.3. Nice job. Now, if you got like 12.5, Something's up with the calculator. Because I did it on here, like I separated it, and it came up 12.5. I don't know how, I don't know why. But I'll show you how to do it on your calculator if you did not get 7.3, not 7.2. If you didn't get it, okay? But if you did end up getting 12.5, let's talk after the lesson, okay? I can't. I gotta show you like individually because the TI presenter doesn't work anymore. I'm sorry. I'm trying. I put in work request after work request. So we'll talk after we're done with this. All right, so we subtract these two. So that means the total area was what? What was it? Total area. Come on now. Last one, guys. After this, we're done. You don't have to hear me talk for a whole week. Well, maybe a little bit for the end of the class, but what's the total area? Subtracting those two. 10 pi minus 7.3. Come on. Come on. Yes. 24.1. Thank you. This will be 24.1. And this will be in meters squared. Don't forget your unit. Questions? Comments? Concerns? Get going on your homework. I don't want you to have homework over break. Those of you watching at home, have a great day.